Today we are going to be discussing quantitative analysis for your quantitative studies, going over chapter 18 and 19. So we will start with chapter 18. So you probably heard the common adage that numbers don't lie. Well, however, it's very important that you understand how statistics are calculated and how they might present information in a way that could be misleading. So you will read in chapter 18 at the beginning an example called Simpson's paradox about how sometimes descriptive statistics, when presented without the proper context, can lead to misleading results. So this is definitely something to take in mind when you are interpreting statistics, not only in research, but in your real life as well. So descriptive statistics are all about describing the characteristics of a particular set of data. So they can help you organize the data, summarize it, and help you visualize it to understand what is happening within a particular data set. You might see graphical displays or statistical summaries. And again, like mentioned at the beginning of the chapter, it's important to, when you're working with descriptive statistics, to avoid any misleading interpretations and keep the descriptions to as accurate as possible in terms of how you could describe what's happening in the data. So oftentimes in descriptive statistics, you will see things such as discussions of the variability in the data, relative standing like percentile ranks, and the relationships to help us draw some conclusions. So let's make sure that you understand the difference between descriptive and inferential statistics. So descriptive statistics describe a particular data set. They might summarize that data set. It could include like the mean of that data set, the frequency. It might have graphs representing that, and it is, again, comprehensive, but also limited to that data set in particular. Now, inferential statistics use a data set to draw broader conclusions, to try to infer based on the data set, infer about the larger population. So in inferential statistics, this is where you will see your hypothesis testing. You might see things like t-tests or regression. And again, those are generalized from the sample. So this is the table that you will see in the beginning of chapter 18. So statistics has two branches, your descriptive and your inferential. And within the inferential, we have estimation. It could be either 1 point or an interval estimating some type of characteristic about the population, or hypothesis testing, understanding the relationship between variables. And it's very common in quantitative studies that you will see both descriptive and inferential statistics included in the analysis. So what do descriptive statistics include? Frequency distributions in terms of frequency count or maybe ranges to show you how many of each different variable or category occurred. You might see graphs, you might see measures of central tendency like mean, median, and mode, the variability across the data set, relationships between variables, and then relative standing. So you will see some examples in the chapter of some of the different graphical displays like bar graphs, line graphs, scatter plots for correlation. Now, I'm also going to show you in this lecture a few examples of some of the data tables that are really common in educational research, particularly in APA style, so you can get some practice on how to interpret both descriptive and inferential statistics when it's presented in a table format. So those measures of central tendency, that is describing the middle of the data set in a few different ways. So you have the mode, which is the most frequent, the median, which is the middle number when you list the numbers sequentially, the one in the exact middle, and then the mean, which is the average of the scores. And so each of these different measures of central tendency have advantages and disadvantages. And so based on the particulars of your data set, one might be more or less appropriate. And one of those considerations is skewedness. So if your data set is normal, meaning no skew, the mean will give you this average right here. However, if you are skewed in one way or another, like a negative direction or a positive direction, as you can see, that is going to shift the mean down or shift the mean up from the overall middle of those scores. In terms of variability, so mean is talking about the middle, and then the variability is talking about the range, how far away the scores are from that middle measure of central tendency. And this is important to show you how the data are spread. So if this was our data set right here, 70, 75, 80, 80, 85. Those numbers appear to be pretty close together depending on the context. However, you could have another data set that also has an average of 80, but the numbers might range from 5 all the way to 200. So this is why it's important to not only look at the measure of central tendency, but also the variability. And some of the different measures of variability include range, the variance, and then the standard deviation, which is the square root of the variance. And here you can see the symbol. You can be on the lookout for this in some of your research articles as well. Now, this variance and standard deviation is using this bell curve to understand a normal curve to help you understand how far the variance in the spread within 1, 2, and 3 standard deviations to help you understand what % of the scores would fall within each of those deviations in a normal distribution. Okay, so let's go ahead and take a look at an example from a research paper. So this is an article from the Journal of Learning Disabilities looking at the effects of coaching on teachers and how that impacts their students. So here is the descriptive statistics table that is being used to describe the characteristics of the participants. So here you can see teacher characteristics by intervention, condition, and teacher group. Now, this is a little bit different than some of the graphical displays in the text that mentioned bar graphs or histograms, but instead here you have some of the sample characteristics. So again, we're looking at the participants just for this sample and limited to the descriptive statistics for this. So here you can see N, which would be related to the frequency, the number within each group for that category. Here we have percentages based on gender. We have age, which would be an average or the mean. And then here is the standard deviation showing you what the spread is or the variance away from that mean for each of the populations. And the reason why researchers give such detailed descriptive statistics is to help a reader get context as to who the participants are, to help ensure or bolster their reliability in terms of confidence that these results can be generalized to other similar populations. So that's why it's important to include those. Here you can see percentages for racial identity of the participants, including the standard deviation there as well. The standard deviation here goes with years of experience. You can see the degree breakdown and then grades taught. So this is an example of what a descriptive statistics table will look like in a research article. This one is describing the participants. Now, another descriptive statistics metric is measures of relative standing. And so we have percentile rank, which is very commonly used in education in terms of test scores such as SAT, GRE, MAP assessment to see how a particular score compares to other scores in terms of relative standing. Is it scoring 85th in a score of 85th in the 85th percentile would mean that that score is higher than 85% of all other scores. So closer to 100, the better score, closer to 0, the lower score. And then we have Z-score, which is also a measure of relative standing. And this is again related to how far a score is from the mean in terms of standard deviation. So finally, in descriptive statistics, we have the relationship between variables, which is so important in quantitative research when you are trying to understand what that relationship is, when you're trying to quantify that relationship, and when you start to begin engaging in hypothesis testing. So we have the correlation coefficient that we read about in the beginning of the textbook. So make sure that you review this. So this will measure not only the strength of the relationship, but also the direction. So it could be negative, it could be positive. And remember, you can have a strong correlation that is also a negative correlation. So as close to -1 or +1 would indicate the stronger relationship. We also have contingency tables, which is cross-tabulation to show the relationship between categorical variables. And this can even be used to make predictions about the relationship between those variables using that contingency table. And then we have regression analysis, which can help you understand and even make predictions about the relationship between quantitative variables. So the regression coefficient will give you the predicted change on the dependent variable based on that change in the independent variable. So this is an example of a regression line between starting salary and GPA. So as you can see here, as the GPA increases, so does the starting salary. And so after running in a regression analysis, and I should mention that researchers often use software, a common program is SPSS, to calculate their descriptive and inferential statistics. And so the researcher could use a program like this to get the regression coefficient to find out the strength of that relationship. Okay, so here is another example from a research article. This is actually the research article that is the sample article critique. And so this is a great example for you to read, not only to understand how to do the article critique assignment, but also to get practice in interpreting both descriptive and inferential statistics. So this article is trying to dig deeper and understand the narrative surrounding the Black-white achievement gap in education. And so this article is using a critical race theory point of view, and it is looking at Black English language learners as a counterexample to disrupt this narrative of the achievement gap, where often Black students are presented as lagging behind their counterparts. This study actually shows an example where the Black students lead other racial groups in terms of their achievement as English language learners. So in this article, the first example that you will see in terms of descriptive statistics is a correlation here. So in the study, they compared two different reading assessments. And so they first wanted to correlate the scores between those two assessments to see if the scores on the state reading assessment were correlated with the scores on the Scholastic Reading Inventory. So here you can get a closer look. So here you can see their scatter plot where they have the relationship. So here they have Scholastic Reading Inventory and the state reading assessment. So you can see that there is a somewhat positive correlation. And here you can see their correlation statistic here. So you can see it is a moderate positive correlation, 0.58. Okay, so on to inferential statistics. So inferential statistics build on descriptive statistics. Frequently, descriptive statistics are carried out first, and then inferential statistics are conducted as well. And the purpose of inferential statistics is to make predictions and estimates about the population's characteristics, and also to test hypotheses in terms of the relationship between variables. So in inferential statistics, researchers use the data from a sample to make probable statements about the population based on the characteristics of their sample. So two of the branches, and this goes back to that table or the figure 18.1, estimation is trying to predict the population parameters, and then hypothesis testing is understanding claims about the hypothesis. Now, descriptive statistics is merely describing the data in a set, whereas inferential statistics goes beyond the data collected to make predictions. So in terms of understanding inferential statistics, so some of the key points are sample versus population. So this is a concept that we've talked about in terms of quantitative studies. The sample are the participants included in that particular study, and then the population is all of the people that would meet those characteristics. Statistic versus parameter. Statistic describes the sample, whereas parameter describes the population. And so obviously, due to logistics, so many logistics, it's oftentimes impossible to study an entire population. And so that's why inferential statistics relies on using a sample to understand what's happening beyond just that sample. Now, again, going back to some of our earlier chapters, it is so important that we have random sampling. And if you have comments as to why, I'm sure you can imagine why it's so important to use random sampling when you are making inferences about a population based on a sample. So go ahead and put your explanations in the chat. Why is it so important that we have random sampling when engaging in inferential statistics? In the chapter, you will also see some tables going over some of the common statistical symbols that you will see. So this is something to keep your eye out for because this does take practice as you are reading research articles to become familiar and fluent in these symbols. And so I know I pointed out earlier standard deviation and N for number of participants, for instance. So here you also see regression coefficient, correlation. We've talked about that as well. In correlation versus population parameter. So you can see how that differs there. So in terms of sampling distributions and estimation, so the sampling distribution is calculated from many samples that are drawn from the same population. And based on that, you can have a confidence level and interval. So when you have a confidence level, that is showing that you are confident to that particular percentage. So for instance, we are 95% confident that the true mean falls within this range. And so you can have a point estimation and then interval estimation. So point would be a single point, and then interval would be a range. So point would be a GPA of 3.2, and then an interval would be between 3 and 3.4 at the 95% confidence interval. And there is an interval table in the example article as well. Now, this can help you and helps researchers when they are calculating the standard error, because in inferential statistics, since they are not able to collect data from the entire population and they are using a sample instead, there is assumed to be a degree of error that is based on several different factors, but a big one is the sample size. So let's go on to hypothesis testing. So hypothesis testing is a big component of inferential statistics and a big aspect of quantitative research. So here are the steps in hypothesis testing. So first, the researcher will state their hypothesis. The null hypothesis would be there is no difference between the two groups or three groups and so on and so forth. And then the alternative hypothesis is that there is a statistically significant difference between the groups. So after stating the hypothesis, the researcher will set the significance level. So the probability value and the significance level are different. So before engaging in hypothesis testing, the researcher will choose their significance level, which is indicated by alpha. And so it's typically 0.05 or even smaller 0.01. And so then after setting the significance level, the researcher will calculate their whatever test that they're doing, select the test, calculate their statistic, and then determine the p-value and compare their p-value to their significance level or alpha. And if their p-value is less than alpha, then they can accept the alternative hypothesis. If it is less than their significance level, they would fail to reject the, they would accept the null hypothesis and fail to reject the alternative hypothesis. So here are some of the key concepts for hypothesis testing. The p-value is the probability of that result being because the null hypothesis is true. So that's why the p-value, a p-value of 0.05, it means that there's only a 5% chance that there's actually no relationship between the variables. So that's why we say in research that it doesn't prove, but there's evidence of. And so the probability value shows you the kind of like confidence level, how sure the researchers are. In there, we also have errors. We have type 1 and type 2 error, type 1 being a false positive and type 2 being a false negative. And again, the effect size will help the researcher understand and interpret the magnitude of the difference between the groups to help understand how big of an effect is happening in the population. So again, in terms of the sample size, this is why sample size is a big consideration in quantitative research, because a large sample can make even a small difference in the mean actually be found significant statistic depending on the particulars. So also with that, the context really matters for interpretation, so do be cautious. So some of the common methods that you can use for hypothesis testing are t-test, ANOVA, chi-squared, and then correlation, and then also a regression. So let's talk about each of those. Okay, so first we have a t-test for independent samples. So this is when you have a quantitative dependent variable like test scores or salary, and then you have a categorical independent variable with two groups. So could be the control group, the experimental group. So an example of that would be if the research question is based on if students in a traditional classroom perform differently on a math exam than students in a flipped classroom. So the outcome is the test score, which is quantitative, and then the classroom types are categorical. So that's one instance of when you could use a t-test for an independent sample. So next we have one-way ANOVA, analysis of variance, or you could have two-way ANOVAs. So this is when you have a quantitative dependent variable, and then you have a categorical independent variable, and you can use this with 3 or even more groups. So this might be a school district is comparing the average starting salaries. So that would be a quantitative dependent variable from graduates of different majors, which is your categorical independent variable, such as education, business, and art. So ANOVA, and again, researchers would use a program like SPSS to calculate this. ANOVA could help you find out if there is a statistically significant difference between those. ANOVA is also sometimes called an F-test. Now, if you do find a statistically significant difference in your ANOVA, you can follow that up with a post hoc test to help you understand which groups were significantly different. So again, if you have your 3 groups, it would help you understand which ones are statistically different. We also have t-test for correlation coefficients. So we've talked about correlation coefficients quite a bit. And so the t-test would tell you if it is a significant correlation or not. So again, this would be both variables are quantitative, and you want to understand, is there a statistically significant relationship between them, such as GPA and, high school GPA and college GPA would be an example. Then we have t-test for regression coefficient, when you want to use that correlation to make a predictor to see if the independent variable is predicting the dependent variable. So you have one or more independent variables and you are trying to understand, like in multiple regressions, and you're trying to understand if that would predict a quantitative dependent variable. So for instance, and this is very commonly used, a university wants to predict graduates' earnings based on their college GPA and GRE scores. And so they could use regression to test whether each of those variables would help explain salary differences or predict salary differences. Then we have the chi-squared test for contingency tables, and we talked about that in descriptive statistics, and now we can take this to inferential statistics. So chi-square can be used when your variables are categorical. So remember, quantitative research doesn't have to just use numerical variables, it can use categorical variables. So here you would want to test whether there's a relationship between the categories. So for instance, the admissions office might want to know if college major differs by gender. So they could compare the percentages of men and women in the different majors, such as education, business, and science, to see if there is a significant relationship there. So here is a little overview for you here. Let me make this a bit easier to read. So here is a table of your different tests and what the independent variable and dependent variable would be like, and the particulars such as one group, two groups, prediction, so on and so forth. So this might be something that you pause and come back to if you are working on a quantitative research proposal, or even during your article critique if you want to come back and check their statistics. Okay, so let's take a look at one last data table. This is again from the article used for the sample article in the article critique. So in this article, they used both multiple regressions and also ANOVA, in addition to the correlation that we already looked at. So this table includes a few of those different tests. So here we have the state reading assessment and the scholastic reading inventory, those two reading assessments that they already found the correlation between. So here you can see the F statistic, which goes with the ANOVA. You can see the p-value associated with that F score. So here you can see for the state reading assessment, the ANOVA did find a statistically significant relationship. And so based on that, they rejected their null hypothesis because the p-value was less than their significance level of 0.05. Here you can see this, and then also in the text, they talk about the results of theirs post hoc and the significance that they found there. Now here you also see another statistically significant p-value, and this is showing that Black language learners outperformed the other races on this particular reading inventory. So here you also, just a couple other things to point out on this data table. We talked about standard error. You can see that here. And I don't think I showed this data table in this lecture, but you will see it in the article critique. Some of the standard error and effect size that they have in this one came from some discrepancies in their sample size for the different racial groups. So this is an example of one of the data tables that you will see, and when you do the article critique, you will see some more comments and explanation from me about these different statistics. So please put your questions and your examples and definitions and help for us in the chat.